I am Professor Antonio S. Marahas, and this is Digital Technique Fundamental. Let's have another example. Let's say you have a given number, say 3C5 of base 16. We want this converted into letter A, base 2, letter B, base 10, and letter C, base 8. Okay? So, again, the first step is for you to convert the given number into base 2. So, if this is base 8, for example, again, the process is to convert that into base 2 and then convert from base 2 to another number system. Okay? So, in this case, 3C5 base 16, we want it converted to base 2. So, for letter A, solution for letter A. So, 3C5 base 16 to base 2. So, again, 16 to the 1 is equivalent to 2 to the 4. Correct? In other words, every hexadecimal again is equivalent to 4-digit in binary numbers. So what is 3? So again, we make a series of 1, 1, 2, 4, 8. You have 4-digit. The maximum number in binary form is 1. So you have series of 1, 1, 1, 1, 1. And this is base 2. 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, and so on. Okay? So, you find, say, 5. What is 5 in base 2? So, 5 here is 4 and 1. 4 plus 1 is 5. So, you make this 0, and this one here is 0 also. Then, what is C? C in the decimal number is what? A is 10, B is 11, so C is 12. Okay? So what is 12? 8 plus 4 is 12. So you make this 1, 1, the rest is 0. So again, this is 5, and this one here is C, or 12 in decimal. Okay? And then you have 3. So where's 3 here? 2 and 1 is 3. So, you make this one here, 0, 0, then this is 1 and 1. You have 0, 0, 1, 1, that is 3. Okay? So in other words, the binary equivalent of 3C5 of base 16 is equal to, what is 3 again? 0, 0, 1, 1. Okay? It should be in 4-digit. Even if the numbers here are 0, you have to rewrite, or you have to write 0, 0 as part of the answer, because it is 4-digit in every hexadecimal number. Then you have C, you have 1, 1, 0, 0. So you have 1, 1, 0, 0. And then 5 is 0, 1, 0, 1 of base 2. That is the answer for letter A. Okay? So 3C5 of base 16 is equivalent to 0, 0, 1, 1, 1, 1, 0, 0, 0, 1, 0, 1 of base 2. Okay? Now, how about 3C5 converted to base 10? So, letter B, 3C5 of base 16 to base 10. Okay? So again, we make use of the binary number that we have already obtained. Again, anong binary number atong gamiton? Because as I've said, in this method, the short method, we make use of binary number system as our reference number system. So we just rewrite this one. So you have 0, 0, 1, 1, 1, 1. Then you have 0, 0, 0, 1, 0, 1 of base 2. We want this converted to base 10. Okay? Ang base 10, wala siya itawag na ito nga boundaries nga i-consider. Straight lang gid siya. Okay? So what do you mean by straight? So it should be represented by 1, 2, 2 times 2, 4, 8, 16, 32, 64, 128, 256, 512. Okay? So 0, 0 na siya. Supposed to be, this is 1024, 2048. But since 0, 0 naman siya, pwede na siya nga wala. Okay? So diyan ang tama. Then you add numbers with representation of 1 in the original numbers, no? You get the decimal equivalent of that particular binary representation. For example, this one, 512 plus 256 plus 128 plus 64 plus 4 plus 1. So you add that will be the answer or the base 10 equivalent of that particular binary number. And what is that? 512 plus 256 plus 128 plus 64 plus 4. By the way, this is plus 1, no? Plus 1. So you have 10, 20, 25. Carry 2. Okay? So you have 7, 8, 10, 16. Carry 1. So you have 7, 8, 9. 965 of base 10. Okay? So the answer is 965 of base 10. Correct ba siya? Atong i-check na. 512, 256, 128, 64, 4, and 1. You have 2 plus 8, 10, 20, 25. 2, 3, 8, 10, 16. Carry 1, 6, 8, 9. So 965 of base 10. Okay? So in other words, 3C5 of base 16 is equivalent to 965 of base 10. So how do we do that? By converting 365 into base 2 and base 2 to base 10. Okay? Well, base 2 to base 10 without boundaries. Then, what will be our solution for letter C? Letter C is 3C5 of base 16. We want this converted to base 8. Again, we make use of the decimal number that we have obtained earlier, and that is in problem A, solution A. So we rewrite this binary number. So again, this is, since 3C5 of base 16 is equivalent to 0, 0, 1, 1, 1, 1, 0, 0, 0, 1, 0, 1 of base 2. Okay, we want this converted to base 8. So again, you have 2 to the 3 is equivalent to 8 to the 1. 1 octal number is equivalent to 3 bits in binary. So, since binary number is already given, you count the number of digits from right going to the left and place a boundary. 3 digits from right going to the left. So, 1, 2, 3. You put a boundary. 1, 2, 3. Another boundary. Okay? Then, 1, 2, 3. Another boundary. So, since we have also 3 digits here, no need to add. No? Na-square na tanan ang atuang numbers. So, again, you write here, this is represented by 1, 2, 4. Since there is boundary, you start again with 1, 2, 4. Since na boundary, you start again with 1, 2, 4. Boundary. So you have 1, 2, 4. Then you add 4 and 1, which is 5. Then you have zeros here. So you have 0. Okay? Do not neglect the 0 here because it will affect our answer. So you have 4 plus 2 is 6 plus 1 is 7. Alright? Then 1. So the final answer therefore is equal to 1705 of base 8. So 3C5 of base 16 is equivalent to 1705 of base 8. Okay? So that is how conversion between bases short method is being performed. No? Again, base 2 should be our reference number system. Before converting to another number system, we have to obtain first the binary equivalent of that particular number system.